Hello, everyone. My name is Hardik from Learn Web3, and welcome to day two of the Decentralized Intelligence Hackathon workshops. Now we have Akshaj from Wormhole here to talk about building a cross-chain dApp using Wormhole. I know a lot of folks have been interested in this, so super excited for this one, and I won't take up too much of your time. Akshaj, if you'd just like to introduce yourself, and then let's get started.
Hey everyone, I'm Akshaj. I'm a software developer at Wormhole, and I'm excited to tell you guys about how to write cross-chain apps. Can you guys hear me? Everything okay with audio? Amazing. Um, let's get right into it. I'm going to try to make this as interactive as I can, so I'll try to ask questions periodically. But yeah, first, as a quick chat question. How many of you guys have experience with Solidity? Somewhat? Perfect. Okay, okay. That's good. Okay. So you guys can all see the slides, okay? Nice. Let's hop right in. So here's an example of an application on a single chain. This is a sample Solidity program. Solidity is the language used for uh, Ethereum smart contracts. And this is a very simple smart contract, hello world, with one function, the function of letting users cause an event to be emitted on the blockchain. So with this function, if a user calls it, the event greeting received is going to be permanently stored in the blockchain logs. Uh, this is a very nice application. It does exactly what it is intended to do. The crucial thing, though, is the user needs Ethereum. They need Ethereum tokens in their wallet in order to use this smart contract. And that is because it costs gas to perform this operation. If you want to have the event emitted on Ethereum, you need to pay in Ethereum for gas. Yes. Uh, if you want to use a different blockchain, if you are not an Ethereum user, let's say you are an Avalanche user, you do not have any Ethereum tokens in your wallet. Instead, you have Avalanche tokens. Well, it's okay. You can deploy the exact same smart contract onto Avalanche, and then the user can cause this event to be emitted onto Avalanche as such. The exact same code, everything works. We're all good. And if you're a Polygon user, you have neither Ethereum nor Avalanche in your wallet. You have Matic tokens. You have Polygon. Uh, you can interact with the same contract if deployed on Polygon. The exact same code, and you're all good to go. However, imagine if you want to cause an event to be emitted on Ethereum and you only have Avalanche tokens in your wallet. You're out of luck, unfortunately. There's no way for you to cause this event to be emitted because you need Ethereum as gas, not Avalanche. And same thing for the other way around. If you have Ethereum, but you want an event to be emitted on Avalanche, there's nothing you can do. And this is not just true for Ethereum and Avalanche. You can take any pair of distinct blockchains, and unfortunately, you can only interact with a blockchain if you have tokens of that blockchain to pay for gas. You need the gas tokens. Um, uh, this graph can be made for non-EVM as well. Like you can add Solana, you can add Cosmos chains here. It's just the case that you need the token, the gas token of the current chain in order to interact with smart contracts on that chain. So today, what we're going to try to do is we're going to try to write applications on EVM only, but this can be extended to non-EVM. We're going to try to write applications such that you can interact no matter what token you have with the application as a whole. So you can cause things to happen on Avalanche if you only have Matic, and you can cause things to happen on Ethereum if you only have AVAX, and vice versa. That's our goal for today. This is a very cool concept. This is not something that is immediately obvious how to do. I hope you guys agree with that. But the goal will be to implement the function spec on the right. The function spec on the left is implemented. It's very clear how to cause an event to be emitted on the same chain. But it is not clear at all how you would even begin to implement send cross-chain greeting to cause an event to be emitted on a different blockchain entirely, specified by the inputs. So now I want to poll you guys and try to see if you have any ideas at all at how we could possibly implement such a function spec. If you were designing a system from scratch that lets you do this, what type of things might you do in this implementation? Give you guys some time to think about it, toss out some ideas. That's great. Timothy, Urmagerd, great responses. That's very similar to how we're going to do it today. But yeah, the idea is have some sort of thing emitted on the current blockchain, and then have an off-chain process listen, and then do the action on the target blockchain. So here's a sample solution. If you were thinking about this from scratch, maybe one solution that you could do is in your function, you could emit a request event, greeting requested, and this indicates that a user has requested for a greeting to be sent to the following chain at this address and this greeting, and it comes from this sender. And then you have some off-chain process. Some call this a relayer. It's just any off-chain script. You can just have it watch for these events on the source chain, and then use payment. It has the payment for the target chain, and it does the action on the target blockchain. So let's say you're on Ethereum, you call your send cross-chain greeting, it emits a greeting request event on Ethereum, and then a relayer or an off-chain script sees that and then brings it to Polygon and calls a greeting event emitting function on Polygon. Any thoughts about this solution? Any problems? Any initial things that stand out? That's an incredibly good point, Timothy. The off-chain script has no money. The off-chain script in this solution would be doing everything pro bono and would eventually run out of funds. Maybe someone would just attack it. It's also centralized, so the off-chain script might just disappear. Like someone just destroys the server, and then you're out of luck. So these are all good problems. I think there's a bigger problem related to centralization. I think centralization is like touching on the issue. There's a bigger problem here where not only can the off-chain script go offline, it can be malicious and do things incorrectly. So the off-chain script can claim that someone else sent greeting, right? When they didn't. And now you have fake greetings on different chains. Exactly. Yeah. Oh, that $100 million was for me, not you. And that is not good outcome of such a system. Um, so that brings us to a point. How can we prevent the falsification of greetings? If we can prevent the falsification of these greetings, we have a much better solution. And that's where Wormhole comes in. Wormhole is a system that lets you send messages between blockchains and get them attested to by 19 reputable organizations in a 2/3 quorum fashion. And what happens is you can now spin up your own off-chain processes that listen not only to the target blockchain, but to all of these organizations who attest the validity of messages from each blockchain. And if 2/3 of these 19 reputable organizations agree that the message is valid, you can now have some trust in the validity of a greeting and bring it to the target chain. That's the power of Wormhole. Wormhole at its core is a messaging solution that uses a proof of authority system to give you some certainty in your cross-chain messaging. So our solution 2, our upgraded solution, works as such. We have our send cross-chain greeting function. We emit some sort of an event. These 19 entities are watching all of the blockchains and stamping their signatures on each event. And then we form this structure called a VAA, which is an acronym that just represents a message along with 13 of the 19 signatures, 2/3 of them. And with this object, with the greeting or any message, along with all the signatures, we can then bring it to the target chain, and the smart contract on the target chain can verify each of these 13 signatures and thus have some trust in the contents of the message. Any questions about this architecture? Perfect. Who decides the 19 guardians? This is just a fixed set. This is a fixed set of 19 entities that will grow over time, but it's currently at 19. And these are just 19 big names in the blockchain infrastructure space. And yeah, so your question now is, okay, I want to make use of this infrastructure. I want to be able to send messages and get these 19 entities to assert validity to them. How do I do that? We provide you two endpoints, a send endpoint and a receive endpoint. And if you use these endpoints, everything else is done for you. If you send this message, you will immediately get 19 entities to assert validity, and then an off-chain script will bring your message to the receiving end, and you can perform your verification and thus know that you have truthfully received your send message. So there's only two endpoints that you have to take care of, your source and your receiving, and then everything else happens automatically. This is for EVM only at the moment. Wormhole actually lets you do EVM and non-EVM chains, to answer your question. So Wormhole at its core supports many blockchains, Ethereum, Solana, Cosmos. You can check on the website for the list of all the ecosystems that are supported by Wormhole. This helper system on top, which is what we're going to work on today and what I'd recommend you guys work on for the workshop, this helper system on top we're terming automatic relayers. It's a set of, it's basically smoothing the experience for developers. And this is currently only available on EVM. But once you have figured out how to write an app using the automatic relayer infrastructure, you then can write your own relayers and perform non-EVM attestations using the 19 guardians. And yeah, I can link you guys to lots of documentation. But for now, let's dive right into the EVM source and receiving contracts right now. Okay, so as I understand it, you guys are, if you guys want to work on a Wormhole application, we put together a nice starter repo and starter instructions, installation instructions that should help you out on your journey. So I'll do a quick little demo right now of how one would write a Wormhole app very quickly in a hackathon setting. And I'll then show you guys the links of all the resources that will help you guys if you guys are wanting to write these apps. So this is the installation link. I'll also send out a link to the slides in the chat. Let me do that right now. The first one should have many important links that will help you guys in your journey. But yeah, for now, let's dive right into the code. So let me shift my shared screen. How's the zoom? Is the text visible? Nice. So once you follow all the installation instructions, don't do it now. Do it on your own time. But once you follow the installation instructions, you should be presented with a sample repository with easy steps in the README to test the code and deploy to testnet, as well as test in testnet. But for now, I'm going to start in a starter branch. So here is some starter code. As you can see, our goal is going to be to cause a greeting to be emitted on another blockchain. We want to write a function that causes a state variable and an event to be emitted on a blockchain of the user's choice. So here's our starter code. We have a constructor. We have our state variable. This is going to be the greeting that we're going to update. And what's going to happen is this smart contract is going to be deployed on both the source and the target chain, on Avalanche and on Celo. And then we're going to be able to call a send function and a receive function. And so we'll call the send function. And then that will cause an off-chain actor to call the receive function on the right target chain. So let's do it. Any questions about this starter code? Feel free to take some time to take it in. I want to make sure we're all, there's no like confusion points on what I'm about to do. Looks okay so far. Nice. Okay. So let's write the receive function first. First, let me run the forge test. Another utility that we provide for you guys is a very nice Foundry testing environment. Foundry is a framework that is very useful for deploying and writing smart contracts, and um, it has a very nice testing framework as well. So, for example, here's the Hello World smart contract that was in the slides, and then here's a nice little test of it, and you can see you can deploy a Hello World contract in your test, and then as a test, you can send the greeting and then assert that the greeting was indeed sent. So now our goal is, we're gonna first write the receive function. So what's gonna happen is the off-chain relayer will call receive wormhole messages with a payload. And this payload is whatever we sent. And what we're going to send is information about the greeting and the sender of the greeting. So step one, we'll just decode it. String memory greeting. We'll decode it from the payload using the ABI decode function. And now once we have the greeting, we'll set our state variable latest greeting to be greeting. And we'll emit an event. We'll emit this event with the greeting, the chain that it came from, and the sender. So, latest greeting. We're provided with the chain that it came from right here. And then one last thing, we're going to want to make sure that no one else can call this endpoint other than the relayer contract. We deploy a relayer contract on the source end and the target end that manage all of the relayers. We're going to want to make sure that everything goes through this endpoint so that no arbitrary person can call this endpoint and cause an action to happen. So we'll just add a line, require message that sender is equal to address of wormhole relayer. And that's it. Any questions about that? Glad to hear you've contributed to Wormhole, guest 3751. Okay, this is perfect. With this function, external actors can now call this contract with greetings. There's one thing missing though. Actually, no, there's not anything missing. One thing that you should ask is, why are we not verifying the signatures of the 13 of 19 guardians? Remember, we wanted to make sure that this thing was valid. Like, we want to make sure the relayer can't lie. Where is that verification happening? That verification happens in the Wormhole relayer smart contract. We deployed a contract that manages all these relayers, and this contract has a function that verifies the VAA, the set, the meth payload, as well as the 13 of 19 signatures, and then it calls this function. So the verification is happening, and that's the reason for this line. Okay, we did that. Let's go to the next step. We have our receive wormhole messages. Now we need to call. We need to send the message. We're now thinking about the source chain end. We want to send the message. There was a great question earlier about how is the relayer paying for the gas? Are they just going to pay it out of pocket? How is that sustainable? Like, is it just doing it out of kindness? No, we have to pay the relayer. So how it works is the relayer provides a fee on a certain gas limit on the target chain. If you want to use some amount of gas on the target chain, you need to pay some amount on the source chain. And how we're going to do that is we're going to call the quoting function. So that is just cost is equal to wormhole relayer dot quote EVM delivery price. And we specify the chain. We specify a parameter regarding to how much message.value to pass in, which we don't need any of. But crucially, we want to pass in the gas limit. So we can set gas limit. We'll set this right here, 256. We'll need maybe 50,000 gas. So if this is how much we need to pay, we need to make sure that the user passes in that much as message.value. And then all we do is we call the send function. We just do wormhole relayer.send payload to EVM. It filled in the parameters, target chain, target address, payload. This is 0, and the gas limit. But what do we want to send? Any thoughts in the chat of what we want to send as the payload? Remember how we decoded the payload in the receiving end? Absolutely, we want to send the greeting, but in what format? Exactly. We want to not only send the greeting, but we also want to send the sender, because we use that on the receiving end. So let's send both of them. Exactly, API.encode greeting message sender. And that's it. We're done. I'm going to forward the test. And if you look at the test, oh, there's some error. I gotta debug. No worries. But yeah, that's basically it. I'm going to run this test in this completed branch. And you can see in the test we send, I'll look up there, I'll try to figure out the error later, but here's the completed code. We send the greeting in the test. The off-chain relayer runs, and then we check that the latest greeting on the target chain is hello wormhole. And it works quite simply. And you can see the code. There's this little extra line here for preventing duplicate deliveries, but this is pretty much exactly what we coded together. And yeah, thanks guys for listening. If you guys have any questions, feel free to shoot me an email. Let me share that. And again, the links that I sent earlier in the chat are specifically the install one, uh, tinyurl.com DIH wormhole install. This link specifically has many links within it that encompass a variety of resources, including the repository that we use here that will help you guys in your journeys of writing cross-chain apps. So yeah, thank you so much. Yeah, good luck on your journeys.
Perfect. Awesome. So thank you, everyone. I'll make sure to include these links in the YouTube description and share them on the Discord in case you missed those. But yeah, thank you, Akshay. This was very helpful, very straightforward, which I like. And obviously, everyone can go and look at the README as well for any further questions. But yeah, thank you for the workshop. Thank you, everyone, for joining. And we look forward to seeing what you built with Wormhole. I'm excited. Awesome. So